Hi, this is impact-proof case that I use to keep my GPS receiver. So this is the original box that comes with this device. It's quite big. It's difficult for me to carry this case into the plane. So this case is much smaller. It's just a cheap impact-proof case. When I bought it, it comes with a sponge like this, and it's already pre-cut into a small cube. All I have to do is just pull it into the shape of the device that I'm going to put into the case. But the sponge is very soft and this one is very heavy. So in this video I will make a new cushion. But first I will 3D scan inside of the Pelican case. If you look here, the case is a little bit of taper. So it would be easier to just scan the inside of the case, and then I will make a 3D scan of the GPS receiver, and then I will reverse in the CAD software and make a cutout for the GPS receiver, and then I can use this CAD model that I make to make foam cutting, or I can just print it with the TPU because the box is only 26 centimeters, so I can print this with my printer. Okay, this is my LiDAR scanner case. I want to show you this. Okay, if you look closely, you will see how they make a cushion. So they make a cutting pattern for the foam layer, and then they glue it together. See here. It's a layer of the foam about 5 millimeters. Some is thicker, some is thinner. So in this video, I'm going to reverse the Pelican case, and then I will make a cutting pattern for the foam. So if you have a small laser cutting machine, you can cut the foam layer by layer like this and glue it together. Genuine Pelican case. See here. The material is much better than the clone one. And this is Raptor X Pelican case, so I don't think it's Pelican because the material is different. And this one is genuine, and this one is. So I used the Raptor X for making a 3D scan in this project. Even though I'm in the office, but I like to connect it to the Wi-Fi handle because the Raptor X needs to have a 12 volt power supply. It's much more convenient. So if you look at this chunk of wire that you need to put on the floor, because I want to scan inside the box, and I may need to turn the box in a different direction to get the sidewall scan. So I need to put the sticker marker. The spacing for 34 lines blue laser is about 10 centimeters. You can always add the markers later, and keep your unused marker away from the detection range of the scanner. It doesn't have to see this, so I keep it away. Okay, I will connect my PC to the Wi-Fi handle. Okay, now it's connected. And next I will connect my phones to the Wi-Fi handle. Next I'm going to make a new project. Okay, I'm going to use 2.5 will be enough. Yeah, I'm going to do a scan in a cross line with automatic exposure. Then I'm going to do a QR code scanning. Now if I click on the full screen, the screen is mirrored. Put the phone to the magnetic here. Let's do a scan. At this point, I start to see that the scanner pick up the point cloud a bit slower than usual because the box is black and shiny, especially in the corners. It won't pick up the point cloud as much as the flat bottom plate. Yeah, the box is black and shiny and it's deep inside, so probably spray will help. Okay, let's try the spray box. Yeah, the spray helps. So you should spray. If the box is in black color, it will scan faster. Yeah. Yeah, I should have sprayed. The point cloud pick up very fast if I use spray. Now it's all green, 0.25 millimeter resolution. So you probably need a spray. This should be enough. Click on stop, complete the scanning. Okay, next I will make a 3D scan of the GPS receiver. So I will put it on a clay so it won't be moving while I was turning the table. It's small enough for 34-line blue laser to scan without applying the markers onto the object. I will add this just in case. So anything that fits into this table will be able to scan without applying the marker onto the object with the 34-line blue laser. Table is about 70 centimeters. I add a new scan. This one 0.25 because you can use a minimum 0.2 for a 34-line blue laser. Okay, now I will start with the global marker first. This will only take a minute. Okay, done. If you look at the screen, you see that the marker is captured. Now I'm going to scan for the point cloud. Do this every time. So I connect it here. Sometimes I feel like my phone is falling off. Okay, start it. Right, so it's pick up quicker if the color is not black. I mean, for the 34-line blue laser, black color, you see the black label on the object is not. I think I should put some marker on here for merging. This will be used for alignment in case of it cannot align. I hope I didn't move it. A 4 would be enough. Okay, so now the new added marker should be captured. Change to a 7-line to scan the black part. See the black wrapper? If I use 7-line, it can capture. So the 7-line blue laser is better for capturing black objects. Okay, this should be enough. Yeah, you can't rotate and orbit the screen on the PC. See here, it's moved too. But you can't do this on the phone screen, which is very unusual. Okay, next I will make a 3D scan on the other side of the object. Start the scan. Okay, done. I will start with the GPS receiver. So I have a 0.25. Okay, move to the second part. Okay, I will merge the scan 1 and scan 2 together. Let's try auto merging, but I don't think it will merge. I think auto merging is working. It's incredible. Yeah, it's work. Okay, this should be the front. I will leave it. Okay, I will try 0.25. Let's see format. Okay, the Pelican Case file is about 100 megabytes and the GPS receiver is about 58 megabytes. So I start to align the case, Pelican Case first. Click here, click apply. I'm going to change the color to a bright color. Let's set it to yellow. And as you can see here that the box is not in XY plane. So I will put this box into XY plane by clicking on this icon here on the left menu. 1, 2, and 3. Now you can see here on the lower right corner that the box is aligned to the XY plane. Next I will align the box to X-axis. I do this by rotate it 90 degrees forward forward. Okay, I will move it to the corner of my monitor, and then I will use my mouse to rotate. Okay, this will be very close. I'm going to save it as the LS files GPS receiver. See here, it's not aligned to the XY plane. This one I changed to clean. Click here. 1, 2, and 3. Okay, now it's aligned to the XY plane, but the Z-axis is upside down, so we will flip it 180 degrees along X-axis. Okay, now it's flipped. I want to rotate this along a Z-axis. Make this alignment. The mounting point and the port cover to be aligned along the X-axis. See here, it's all straight up and parallel to XY plane. I will save this one as the LAS format. Okay, here's in Autodesk recap. I will change the origin point. 00 will be here. So I just save it. I'll click on Manage, Attach, Pelican Case, and now I scale it 0.001 and insert at the origin. Okay, now we have a box here. Change the color to dark mode. I'm going to create a file, Fusion. Next, I'm going to create a line, horizontal line. As you can see that the box is aligned to horizontal line already. I will create the base of the box, say somewhere around here, and then I'm going to make a fillet. Okay, now 10 is too much. Change it to 6. I'm gonna move this one down a bit. I need to move the point cloud up a bit. I move it up 2.3 millimeters. I still have the line. Alright. Next, I will create a second sketch. Move this to the top 90 millimeters. Click OK, and I make a second sketch. Let me crop. I will crop the point cloud. So I crop just the top part here. Next, I'm going to make a square. Everything. Then I'm going to make another fillet. Okay, 10. Finish the sketch. Next, I'm going to loft these two profiles together using a loft command. Section. And second one is this one. So it will loft this into a solid. Okay, let's uncrop it. Yeah, it looks quite alright. You see that the point cloud match. Okay, I will chamfer this to right about this. So now we have I move this one in just a bit, and this one just a bit, because the bottom of the Pelican Case is not flat, it's curved up. A second point cloud, the GPS unit. I will move the GPS unit to the center, 00 coordinate to the center here. First, I will draw circles, and these circles is 11.087 millimeters. I will move. So now the GPS unit is in the center. Okay, next I will create a solid for the GPS unit. I would say this has to be a little bit bigger. And this one, let's say 20x, 22. Then I'll make next I will extrude this one. You can see that 18 millimeters. Okay, next I will make a box crop. Cut a very thin layer here. Okay, we have a box crop. Create a sketch on the XZ axis. Going to project the Z axis. Draw a sketch. Make a curve just a little bit bigger. Make a straight. This one will be. Okay, now I'm going to make a revolve along the axis. Okay, next step, I'm going to create a new component. Don't need any sketch. Then I will delete the part, which is the cushion, and delete the second part, it's a GPS unit. Okay, now the leaf part is on the XY plane, so I'm going to move the GPS unit up a bit. Move up here. So next I will cut using a combine command, base body and the two bodies. Subtract. Now we have a cushion cutout blue. So I jump for 3 millimeters. I will create a sketch for about 25 millimeters to here. So I cut it so that I can put my fingers in there and pull out. The cutout is larger than the object, so it should be able to fit easily. And if you want to cut into the foam layer, see, if your foam thickness is 10 millimeter, you can create a sketch and make a cut edge here. Now you're going to have a sketch for cutting your foam, and you can export the sketch into DXF or DWG format and use it for cutting the foam sketch section of each foam sheet in layer like this, and export it to a CNC cutting machine to cut the foam into different patterns and glue them together with the foam adhesive glue. Because if you print with TPU, it would cost a lot of money because TPU is more expensive than other filament, and it takes a really long time to print. I think in my location I can find a foam cutting service, but if I can get the drawings to them, they can cut in a specific sheet for me and probably glue it together. So I think that the best way to save filament is just to print the support only half, about this height. Cut it down 35 millimeters. If I print in half height, I will move the GPS unit up 1 centimeters, and I will also move. Okay, now the lid should be pressing the GPS unit to hold it into the box and not moving. Okay, let's send this for printing. Okay, here's the printing. I don't print this in a TPU because TPU is deformable, and I want to show the precision of the design. And one thing I have to admit is that I forgot to make a cutout in the bottom part, but I forgot to make this cut. It's 8 hours printing time, so I'm not going to reprint this one. Okay, let's test if this design fits into this Pelican case. Okay, it's fit. A little bit of play, maybe because I didn't make that bottom cut here. See here, all the gap fits perfectly. And if I want to lift up, yep. Finger cutout is too small. Actually, it should be around 30 millimeters diameter. I will use the lid to place down the GPS unit a bit so it won't move. So when I close it, see here, it's not fully closed. So I place it down a bit so the sponge will press the object. A good thing about designing a foam cutout in CAD is that when you want to move your object, you have additional object to put on. If you want to move it, the cutout will move along with the object. So there's no need for you to adjust any drawing. You just move the object and it will update all the corresponding drawing. Thanks you guys for watching. I'll see you in the next video.